In this lecture, we're going to see how we can search and find stuff inside an std string. The facility we're going to be using is going to be find. It is a behavior called find on std string. And we're going to just use an example to try and explain this. We have one string here called string1. Inside we have a piece of text which says water was poured in the heater. And we set up another string that we are going to search for in string1. That happens to be ter here. So we can really target the ter in water or ter in heater. We're going to see what we find. So what we're going to do is say string find. Okay, we're going to find something inside a string1, and we're going to specify what we want to search for in the parentheses like this. So if this function finds what we want to search for, it's going to give us the index where that's going to start. If it doesn't find it, it's going to give us a seemingly junk value, and we're going to see that it's going to be a large number. So for example here, ter is going to be found, so we're going to find that at index 2, so 0, 1, 2, that's where ter starts. If we search for red, it is going to find this red here in the poured world, and we're going to find the index. We're going to see that it's a 13. But if we try and search for something that isn't there, we're going to get a junk value, or what seems like a junk value, but it's really not. It's going to be a very large value, which doesn't really make sense in the string here to have a very large index. So what is really returned when we don't find what we are looking for? Let's look at this. What is going to be returned is a really large number, which is going to mean that what you were searching for wasn't found in the string. And this happens to be the same thing we get if we happen to underflow on a size t type. So this is basically telling you what you are searching for wasn't found, and we're going to use a really large index to tell you that. And this was really useful enough for C++ to actually give this large number a name. You can call it stdstring and pause here. And if you try to print it out, you're going to see that it is the same thing we get if we don't find what we want in our string here. And it is also going to be the same thing you get if you try to underflow on a size t. So if we try to print this, we're going to see that they are the same thing. So this is useful now because now we can perform checks. We can say, if the returned index in our find behavior is equal to end pause, we haven't found what we were searching for. If it's not equal to stdstring end pause, we're going to say we found what we wanted, and we're going to say the index where we found it. And this is really cool. So down here we have another example where we search for chicken. We're not going to find this, so we're going to fall in the first block here saying could not find the string chicken. But if we found it, we could say we found it starting at whatever position. This is really cool. We can also specify the search starting position. For example, here we have two instances of ter. Okay, ter in water and ter in heater. For example, we can say start searching from index here on this space or on the n world here, and that way we're going to be sure that we're going to find the ter in the world heater here. And the index you want to search for has to be specified as a second parameter. And if we do this, we're going to find that our characters are either going to be found or not found, depending on what we have in our string. It is also possible to search for the equivalent of a C string. For example, here, our target string is going to be stored in a C string pointed to by C string 2, which is a const char pointer. And we're going to say string2 find. We're going to try and find the C string, and we're going to specify the start index to be 23, and you're going to see that what we want is going to be found in here. These are just a few versions of the find behavior on stdstring. If you want, you can go in the official documentation and really check all this out. You see that we have many versions of find. You can reverse find, you can find first of, you can find last of, you can do all kinds of crazy things. But I think now you have an idea, and you are powerful enough to go and learn and use these things on your own. And I am going to take this chance and show you all the things we have seen about stdstring. Now you know many of these guys. You know how to clear, insert, erase, pushback. You can resize, you can swap. You can really do all kinds of crazy things on stdstring, and it is a powerful type, and I am really excited that we have been able to learn all these things together. For now, we're going to head over to Visual Studio Code and try to find some stuff in our strings. Okay, here we are in our working directory. The current project is searching stdstring. We are going to grab our template files. We're going to put them in place. 15, 14, that's the project. We're going to put those in, and we're going to open this in Visual Studio Code and include our string library. Let's go down in main and put in our first example. It is really simple. We're going to have two strings, string 1 and search for. The string 1 is going to contain the text we're going to be searching again, and search for is going to contain our target text. So that's going to be TER, and we're going to try and find that in this string here. So the syntax to do this is to say the name of the string, the variable name, do a dot and say find, and in parentheses you're going to specify the string that you're going to be searching for. And if it finds it, it's going to give you the index where it found it. So for example here, it's going to find TER in water here, and it's going to say that it's going to start at 0, 1, 2, 2 index. That's where we're going to find our target here. We're going to print that out. If we search for red, for example, we're going to find this substring in the world poured here, and we're going to say the index where we found it. If you count, you're going to see that this guy here is at index 13. And if we're trying to print this, we're going to see the indexes printed out here. Let's bring up a terminal so that we can run this and play with things. And we are going to build with GCC, and we're going to clear. And if we do rooster, we're going to say we found TER on index 2. We found red at index 13. This is what we want. But what if we try and search for something that isn't actually there? Let's see what we get. Okay, we are going to go down and search for chicken in this string here. We are going to search for chicken, and we know that we don't have chicken in this text here. So what are we going to get? Let's try that. We can run this through our compiler. The build is going to be good, but see what is going to be printed out. Let's clear, not clear, and we're going to run rooster. We're going to say index is a really large number here. What is this? Well, it happens this is an internal number that is used to tell you that what you were searching for is not found. And this number is important enough that it actually has a name in C++, and it is stdstring npos. Okay, that's what this guy is. If we try and print it out, we're going to say npos, and we say the value in here, stdstring npos. You see that Visual Studio Code notes that it is there. We're going to put a new line character. And if we try to build and run this, we're going to see that what we print here is going to be the same as the index we got from our search, which failed. So let's try and build this. Hopefully you're going to understand this. And we are going to clear and run rooster. We're going to see that npos is this large number. This is really interesting. So this is the largest number we can represent with a size t. And another way to get this number is to underflow on a size t. We know that size t is some kind of unsigned integer, which is really used to represent only positive numbers. You can't try and put in a negative number. If you try and, for example, put in a -1, we are going to underflow, and that's going to be the largest number we can represent in a size t. We have learned about overflow and underflow in a previous chapter. If that's something that is confusing to you, please go back and make sure you have watched the specific lectures on the topic. For now, we're going to try and underflow on this guy. So for example, we can set up a size t variable. Let's say size t and call this Raj. And we're going to initialize this with a -1 using assignment here. And if we print this out, we're going to see that we get the same number. And again, what we are trying to do here is a sin, because we're trying to put a negative number and something that can't really hold negative numbers. Size t can only store positive numbers. So what is going to happen here, we are going to underflow and all the bits are going to be flipped and be ones. That's why we're going to get a large number the largest number that we can represent in a size t. Let's try and build this. We are going to use GCC, and we are going to build good. We're going to clear and run rooster. We're going to see that large is exactly the same thing. So this is something that we have that we can use to check and see if we actually found what we searched for. So now we can go down and make better searches because we know how to check and see if we found what we wanted. And we are going to be checking our things against stdstring and pose. We are going to comment out what we have here because we don't want all this noise output. We're going to do something else which is going to potentially print out a lot of things. So let's comment this out and go down. Okay, let's go down and put in our example and do the same searches, but now we are going to be checking our results against stdstring and pose. So we're going to search for red in here. We're going to find it. So we're going to say, find our target string and tell us if you found it. The return value is going to be stored in found pose, and we are going to check this against stdstring and pose. If they are equal, we're going to know that we could not find it. If they are not equal, we're going to have found our string at position that was returned in here. This is really cool. We can also search for chicken. We're going to update our search for a string. We're going to search. If we find what we want, we're going to print that here. Chicken was found at position here. If we don't find it, we're going to say that we could not find what we were searching for. And this is really cool. So we can try and build this. Let's build with GCC, and we are going to clear and run rooster. We're going to say red was found at position here, but we could not find chicken, which is really cool. Let's comment this out because we still have a distance to cover in this lecture. It is also possible to specify the index where you want the search to start from. And you say that by passing the index as a second parameter here. Here we have our string. Here is our target string, which is ter. And we're going to say, find this target string and give us the result in found pose. And we're going to print this guy out here. In the first case, we're going to find the position 2 because that's the default, because we're not specifying the index. We're going to find 0, 1, 2. This is the index where the target string is going to start. But in the second example here, we're going to specify the start index as 0. So it's going to basically be the same as the default. But if you look at the third example here, we are going to start searching at index 4, and that's going to be 0, 1, 2, 3, 4. That's going to be on this R here. So we're going to try and find TER starting here. And it's going to go until it hits this TER here. I found it. And it is starting at this index here. That's what we're going to get in here. And we're going to print this out. Let's try and build this with GCC. The build is going to be good, successful. And we can bring this up, clear, and try to run rooster. And we're going to see that for the first case, it was found at index 2, which is the default. We can use 0 as the index. We're going to find the same thing. If we use 4 as our index, we're going to find this at 27. Let's try and search from 28, for example. Let's see what we get. Try to really replace in your own values and see what you get. It is a good way to learn. We're going to build with GCC. Let's clear and run rooster. And you're going to see that, we're not going to find it from this index here. But for example, if we put in a 10, which is way before our target, we're going to find it. Let's try and build with GCC again. We are going to clear and run rooster. We're going to find it at 27 again. So this is how you can specify your own starting index where things are going to be searched for. We are going to comment this out. Let's do that. The next thing we're going to see is that it is also possible to find a C string. Okay, we have our data, target data, stored in a C string called cstring2, and the search string is string2 like always. And we're going to try and target her in this string here. Notice that we have two instances of this. We have her here and her in the here world. So if we try and find this, we're going to see what we get. Let's try and run this. We're going to start at index 23, and if you count, you're going to find that index 23 is somewhere after this her here. So this should give us this guy here, the index where this guy starts. And if you count, you're going to see that it is actually correct. We are going to build with GCC, and the build is going to be good. We're going to clear and run rooster. We are going to find her at position 44. If we change this, for example, to a 3 or a 2, why not? We should get this guy here because we are starting searching somewhere from here. Let's try and build again. And again, the best way to really understand these things is to try and put in different pieces of input and see what output you get. Then you're going to build an intuition for these things. Let's try and build. You see that we get position 20. And if we count here, we're going to find that this guy here starts at index 20. Let's actually count. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20, which is exactly what we have here. So this is really all we set out to do in this lecture. I hope now you have a better idea of what you can do with the find behavior on stdstring. You can use it to find stuff if that happens to make sense for your application. We are going to stop here in this lecture. In the next one, we're going to see how we can transform back and forth between stdstring and numbers. Go ahead and finish up here and meet me there.